Welcome to the Teja Statistics. Today we are going to discuss about this uh, two-phase simplex procedure. Two-phase method is another method to solve a LPP which involves the artificial variables. Two phases of solving a LPP can be explained below. First of all, you have to convert the phase 1. So, we have to phase 1. What you have in phase 1? Let's see. In the first phase, we construct an auxiliary linear programming problem. The construction and solvation of auxiliary LPB can be explained in the following steps. Step number 1. Check whether the given LPP is a maximization or not. If not, convert into the maximization of LPP. Step number 2. Check all BIs are non-negative. If not, convert into non-negative values. Then step number 3. Introduce a slack or surplus variables whatever necessary for the less than or equals to and greater than or equals to constraints. Step number 4. Introduce the artificial variables to the left hand side of the constraint of the type greater than or equals to and so equals to, so that initial basic feasible solution is obtained. Next, step number 5. Assign the cost as -1 to the all artificial variables and cost 0 to the all other variables like x1, x2, x3 and s1, s2, s3 and all remaining variables except our artificial variable. So that one we have to consider as the -1 artificial variable and solve these uh, auxiliary LPP. Step number 6. Consider the auxiliary LPP for which the new objective function z star is to be maximized subject to the given set of constraints. Solve the auxiliary LPP by using simplex algorithm until either of following the cases. Max z star is always less than 0 and at least one artificial variable uh, appear appear in the basis that a positive level, so all jj minus cj's are greater than or equals to 0. Then in this case the given LPP does not possess any solution or feasible solution. Okay, does not possess any solution. Next, max z star equals to 0 and at least one artificial variable appears in a 0 level. All zj minus cj's are greater than or equals to 0. In this case we proceed to phase 2. Okay, next, max z equals to 0, no artificial variable appears in the basis, so all zj minus cj's are greater than or equals to greater than or equals to 0. Then in this case we proceed to the phase number 2. Okay, next, what is our phase number 2? First, we assign the actual cost to the original variables and a cost 0 to all the artificial variables, if any, in the objective function. Consider the original variables and solve. Okay, by simplex procedure. The phase 1 as the initial or starting solution in the phase 2. Now simplex method is applied until either an optimum basic feasible solutions is obtained or unbounded solution is attained. So, during the computational procedure, if any of the artificial vector leaves the basis, we can remove it from the simplex table at the end of phase 1. At the end of phase 1. Yeah, this is a two-phase simplex procedure which we already discussed. Yeah. So what is they are going to say is, first of all, convert the given LPP into standard form, and to apply the simplex procedure we should convert all the subjective constraints into equals to form by applying the slack variables and surplus variables if any is equating to 0. So then only we will get the we will obtain the initial basic feasible solution for the given LPP. Then put the first all data into the initial simplex table and solve it by simplex procedure only by taking the artificial variable cost as -1 and all remaining values of the given data are zeros until and unless you may get the given function is optimized. Then you should go to the phase number 2, otherwise it will be terminated there itself. Next, in phase 2, consider artificial variable if any exist is then the cost of that function in objective is 0. All remaining values should take the exact values of the given LPP or original values of the given LPP. Hence, we can say that it is a two-phase simplex procedure can be applied, and until and unless you have to calculate up to all Zj minus or Cj's are greater than or equals to zeros. Okay, here they are giving in the note that is, once the artificial variable is leaving from the table, then it can't be present in the next table. That's what they are saying in the note. Understood? So this is the concept of two-phase simplex procedure. Okay, write down the notes, and we are looking forward for the examples also. Thank you.
அண்ணன் யாரு